Hi class, welcome to our 2.1 computing unit rates lesson. If you've clicked on this video, I assume that you've already completed the pre-video and all of the problems associated with that, and you've been checked off to move on to our lesson video. So if you've not already done so, go ahead and grab your guided note sheet. And before we get started, I do want to remind all of you, while you're watching this video lecture, it's very important that you listen the entire time that the lecture is taking place. Make sure that you are listening as well as seeing what I write, because there are certain things that I may say that I may not write down that could be beneficial to you understanding and knowing how to work these problems in the future. Unit rate is so important because if we go to a mall and we need to figure out which shirt has a better deal or which grocery item has a better deal, it's important to know rates. So this lesson is actually getting you prepared for a very fun and cool activity that we're going to do at the end of the task sheet. So without further ado, let's jump into it. All right, first things first. A rate is a ratio that compares two different numbers with different units. So when we're talking about ratio, we can reflect back on the fact that a ratio is kind of like a fraction, where we're comparing two numbers with different units. And when we're talking about units, we're basically talking about the things associated with the number. So if we were dealing with dollars, that would be considered a unit. Amount of chips, that's considered a unit. Miles per hour, they're both units. Okay? Next, let's look at an example. So here we have a car travels 100 miles in 2 hours. So in order to kind of write that out, I'm going to first write down in words the two units that I'm comparing, which are miles over hour. And then I'm going to write down the numbers that are attached to that, which are here 100 over 2. So this would be an example of a rate, okay, or how we would write out a rate. Moving right along. A unit rate is a rate that's expressed in the quantity of 1. So in word problems or situations, we're going to see the phrases for every or per another quantity. You always need to know that the unit quantity is always in the denominator. So that means 1 is going to be in the denominator. So if you hear an example, Miss Fersner passes out 5 pieces of candy per group, we're talking about unit rate. Okay? Let's look at a unit rate problem and see if we can solve it together. See, y'all almost made me forget our unit rate steps. Let's get into those real quick. When we're solving any type of unit rate problem, the first thing I want you to do is to write in word form the units that you're going to be comparing. So you're going to read the problem, identify what words we're using for this unit rate, and write those down. Secondly, you're going to set up your rate. And when I say set up your rate, I mean your actual numbers. Okay? And finally, you're going to find the amount for 1. Now, let's look at this problem. A car travels 100 miles in 2 hours. How far does the car travel in 1 hour? Remember, unit 1. So we're trying to find how far it travels in 1 hour. The first thing I'm going to do is I'm going to write in word form the units I'm comparing. And it helps to kind of underline that in your problem. I'm looking at miles and hours. So the first thing I'm going to write is miles over hour. Okay? Then I'm going to come out to the side and I'm going to set up my rate, which means the actual numbers. What number is associated with miles? 100. And what number is associated with hours? 2. I'm going to write an equal sign and draw another fraction symbol. So the question asked me how far can the car travel in 1 hour. So I already know how many hours I'm trying to figure out. But I don't know how far it travels, so I'm going to represent that unknown number by using the variable x. Okay? So now I have 100 over 2 equals x over 1 because I'm trying to figure out how far the car travels in 1 hour. So the next thing I'm going to do is ask myself, what can I divide by 2 in order to get to 1? And the answer to that is I can divide 2 by 2 because 2 divided by 2 is going to give me 1. Now whatever I do at the bottom, I have to do at the top. So I need to divide 100 by 2. And I know that 100 divided by 2 is going to be 50. So here's how I'm going to write that. X equals 50 miles per hour. Okay? Keep in mind that the slash means per. This HR means hour. And it is so important for you to make sure that with these problems, you put your units. If I didn't put miles per hour, what am I talking about? 50 cotton balls? 50 Jolly Ranchers? No. The question asks, how far does the car travel in 1 hour? And my answer is that the car travels 50 miles per every 1 hour. Let's move on to some practice problems. If you want to try these problems out by yourself, you can pause the video here, go work it out, and come back to see the answer. However, if you want to see some of the problems worked out, then stick around. Alright, so the first one. Route 21 is having a sale on shirts, charging $15 for 4 shirts. How much would 1 shirt cost? So using my steps, I'm going to first write in Word the units that I'm comparing. So, the question asks how much will 1 shirt cost? And I know that this dollar amount here equals a certain cost. So the first word I'm going to write is cost per, what am I looking at? The number of shirts. So these are the 2 units that I'm comparing for this problem. Next, I'm going to come out to the side, right beside that, and I'm going to write my fraction symbol. The next thing I'm going to do is set up my rate. Okay? I know that the cost that I have here is right now $15 for 4 shirts, and I want to see how much 1 shirt will cost. I don't know how much 1 shirt will cost now, so I'm going to represent that using the using the variable x. Okay? Now I need to find the amount for 1, and in order to do that, I need to solve this rate. So I need to ask myself, what can I divide by 4 in order to end up with 1? And the answer to that is that I can divide by 4. Now whatever I do in the denominator, I have to do in the numerator, so that means I need to divide 15 by 4. Okay? So I need to come over to the side and do a division problem. So I'm going to set that up over here. Find me a nice marker. Okay, here we go. I'm going to set it up how I can read it. 15 divided by 4. So I'm going to write 15 divided by 4. Okay? I know that 4 can go into 15 3 times. 3 times 4 is going to give me 12, which is going to give me 3. That's not it. I need to keep going, so I need to add a decimal, a 0, and a decimal here. Okay? Bring that 0 down. 4 can go into 30 7 times because 7 times 4 is 28, which would give me a remainder of 2. I'm not finished yet, so I'm going to add a 0 and bring that 0 down. How many times can 4 go into 20? 5 times, because 5 times 4 is 20, which is going to zero me out. And now I'm done. Now I have this answer, 3.75. So this 3.75 is actually going to be my x. Okay? So how do I write that? I'm going to represent that by saying that x equals $3.75, which is the cost per shirt. Why do I say shirt? Because we're only dealing with 1 shirt here. So my answer will be represented like this. Remember that in order for you to get full credit for your problems, you're going to need to make sure you include your units. Now, the only reason why I didn't put 3.75 cost per shirt is because I already know this is $3.75, so I don't need to go any further than that. Let's look at the next problem. Now, this problem says that Cardi eats 1/3 of a pizza in 3/4 hour. At this rate, how many pizzas can Cardi eat in 1 hour? So, now, the first thing we're going to do is we're going to write in words the units that we're comparing. So, Cardi eats a certain amount of pizza in an hour. So, I'm going to represent that by saying amount of pizza per, that line meaning per, hour. That's my word form. Now I'm going to set up my rate. Now this may seem a little strange, but we're going to put two fractions on top of each other. And here's how we're going to do it. Okay? What is the number associated with the amount of pizza? We know that number is 1/3. How many hours did it take her to eat 1/3 pizza? It took her 3/4 hour. Now, you may be wondering, how are we going to do this? We're going to do this the same way we did the above. We need to figure out how much pizza she ate in 1 hour. Okay? Now, let me ask you this. What can I divide by 3/4 in order to get 1? I can divide it by itself. So I'm going to divide the bottom by 3/4. And if I actually work it out, I would know that 3/4 divided by 3/4 is going to give me 1. Because anything divided by itself is going to give me 1. Now, I'm going to do the same thing at the top. 1/3 divided by 3/4. Which means in order to get my x, I need to do this division problem up here. So, let's go over to the side and do it. Okay, I'm going to draw a little squiggly just so I don't get myself confused. I have 1/3 divided by 3/4. I know that whenever I have a division problem with fractions, I need to keep the first fraction, change the sign, flip the second fraction, now multiply. Okay? I'm checking diagonally to see if there's anything that I can reduce, like in our lesson, pre-lesson. And I don't see anything that I can reduce. So I'm going to go ahead and multiply straight across. 4 times 1 is 4. And 3 times 3 is 9. So x is 9. Now how am I going to write that? I'm going to represent that by saying x equals 4/9 pizzas or pizza per hour. So what this number means is that Cardi in 1 hour ate 4/9 of a pizza. Okay? 4/9 is not a whole. So she hasn't even eaten a whole pizza. Just 4/9 in 1 hour. Okay? I want you to see if you can try this third problem. Work it out. Get it checked by me. And when you're finished, move on to the next part of your task sheet. Oh, but before you do that, one quick thing to note. When you finish your guided notes and you get your answers checked, make sure that you turn to a blank page in your ISN, fold this, and glue it in a way that will allow you to open and close it so that you can keep this in your ISN in a neat place and reference it throughout the rest of the task sheet. Happy mathing!